What if everything we thought we knew about the beginning of time was wrong? Picture the deepest reaches of space, not as an empty void, but as a cosmic graveyard filled with faint, flickering echoes of a universe that existed before our own. Scientists have uncovered something extraordinary: 33 ghostly signatures etched into the fabric of deep space, whispers of a past so ancient it defies our understanding of reality itself. These aren't just random signals, they're cosmic fingerprints left behind by a universe that thrived long before the Big Bang ever echoed through the darkness. Think about that for a moment. We've always been told that the Big Bang was the ultimate beginning, the moment when time, space, and matter burst into existence. But what if it wasn't the start? What if it was just another chapter in a story far grander than we ever imagined? These ghost signatures detected by some of the most advanced telescopes ever built aren't just anomalies. They're evidence that our universe has a past, a history written in light and energy that's been hiding in plain sight, waiting for us to decipher its secrets. This isn't just a scientific breakthrough, it's a paradigm shift, a revelation that forces us to rethink the very nature of existence. How did these signatures survive? What kind of universe could have existed before ours? And if time doesn't begin with the Big Bang, where does it truly start? Buckle up, because we're about to embark on a journey beyond the edges of known physics, into a realm where the rules of reality bend and the past isn't what we thought. By the end of this, you'll never look at the night sky the same way again. The cosmos is speaking, and what it's saying will leave you in awe. The Big Bang has stood as the ultimate origin story for generations, the moment when time itself began. But these ghost signatures scattered across the cosmos tell a different tale. Imagine holding a photograph where faint traces of an older image linger beneath the surface, refusing to fade. That's what astronomers are seeing. 33 cosmic imprints that shouldn't exist if our universe truly began from nothing. Some researchers believe these are scars from a previous cycle of existence, like echoes of a universe that collapsed and rebirthed itself in an endless cosmic dance. Others argue they could be fingerprints from a parallel reality, bleeding into our own through some hidden dimension. What makes this so revolutionary is how it appends the very definition of beginning. If these signatures are remnants of a pre-Big Bang era, then time doesn't start, it loops, twists, or perhaps stretches far beyond what our physics can explain. Picture a river flowing backward into itself, or a book where the first chapter is written in ink that predates the paper. That's the scale of the mystery we're facing. Even the most cutting-edge theories like loop quantum gravity or string theory struggle to account for how information from a before could survive the violent rebirth of a universe. Yet here's the most thrilling part. These aren't just mathematical quirks. Telescopes have actually detected them: anomalies in the cosmic microwave background, subtle temperature variations that form patterns older than time itself. It's as if the universe left breadcrumbs for us to follow, clues etched into the afterglow of creation. The debate isn't just academic, it's a race to rewrite the textbooks. Are we seeing the last gasp of a long-dead cosmos, or the shadow of a sibling universe brushing against ours? Either way, the answer will force us to confront an idea as beautiful as it is unsettling: that our existence might be just one verse in an epic poem written across eternity. Among the 33 ghost signatures, one anomaly stands out like a cosmic beacon: the strange ripples embedded in the cosmic microwave background. This isn't just background noise. It's a pattern so precise, so unnaturally structured, that scientists have spent decades debating whether we're staring at the universe's first deliberate message. Imagine running your fingers over an ancient stone tablet, feeling grooves carved not by random erosion but by intention. That's what researchers see in these microwave ripples, a fingerprint pressed into the afterglow of creation itself. What makes this signature so controversial is how it defies expectation. The cosmic microwave background should be a chaotic sea of tiny temperature variations, remnants of the universe's fiery birth. But this ripple, it's too orderly, too symmetrical. Some compare it to finding a perfect geometric shape etched into a random cloud formation, something that simply shouldn't occur naturally. One theory suggests these ripples could be scars from a collision between our universe and another, like wrinkles left in fabric after a tremendous impact. Others propose an even wilder idea, that this is a relic from a previous cosmic cycle, a remnant of physical laws that governed existence before time as we know it began. The most tantalizing part, this signature isn't hiding. It's been visible in satellite data for years, quietly waiting for someone to recognize its significance. When researchers first mapped it, they assumed it was an error, an artifact of instrument noise or interstellar dust. But as technology improved, the ripple persisted, its mathematical structure growing clearer. Now, teams across the globe are racing to decode what it means. Could it be evidence of a universe that recycled itself, a signature left by some unfathomable intelligence? Or simply a quirk of physics we've yet to understand? What's undeniable is that this anomaly forces us to confront a humbling truth. The universe may have been keeping secrets far older than we ever imagined. And if one ghost signature can rewrite our understanding of cosmic history, what revelations might the other 32 hold? The ripple is more than a scientific curiosity. It's the first clue in a mystery that stretches beyond the edges of known physics. The second ghost signature isn't just a whisper, it's a cosmic shout. Imagine stumbling upon a family photo where one person appears decades older than they should be, defying the laws of time. That's exactly what astronomers encountered when they discovered phantom galaxy clusters, enormous structures of stars and dark matter that look like they've been aging in a universe far older than our own. These clusters don't just push the boundaries of our cosmic timeline, they shatter them. Their stars show signs of advanced evolution. Their chemistry hints at processes that should have taken twice as long as the Big Bang's 14 billion-year timeline allows. It's as if we've found ruins from a civilization that predates history itself. What makes these clusters so extraordinary is their precise alignment with theories of a cyclic universe. Some models suggest that when a previous cosmos collapsed, not all of its matter was annihilated. Like survivors of a shipwreck clinging to debris, these phantom clusters might be fragments of that older existence, carried through the Big Bang's firestorm into our newborn universe. Picture tossing a handful of sand into a blazing furnace while most grains vaporize. A few might emerge on the other side, still holding their original shape. That's the scale of survival we're talking about. The most compelling evidence comes from their distribution. These ancient clusters aren't scattered randomly. They form eerie geometric patterns across the sky, like points on a cosmic blueprint. One team mapping them at the South Pole telescope compared it to finding footprints in snow that somehow lead both toward and away from you simultaneously. Even more perplexing, their light carries subtle spectral anomalies, absorption lines that match no known element in our periodic table. Could these be echoes of different physics, remnants of a universe where the fundamental constants weren't quite the same? Mainstream cosmology struggles to explain them. If they were simply older structures from our universe, their sheer size would violate the speed limit of cosmic expansion. Yet alternative theories paint an even more mind-bending picture. In loop quantum cosmology, these clusters might be cosmic knots, regions where space-time from a prior universe failed to fully unravel during the Big Bang. String theorists propose their shadows cast by parallel brainworlds brushing against our own. Whatever the truth, their existence forces us to confront a radical possibility: that universes don't just begin and end, but transform, carrying forward fragments of their past like cosmic DNA. The implications are staggering. If matter can survive between cosmic cycles, then information, perhaps even the imprint of life, might persist across eons. These phantom clusters could be more than relics. They might be messengers holding encrypted stories from a time before time. As new telescopes like the Vera Rubin Observatory come online, their detailed observations may finally reveal whether we're gazing at the last embers of a forgotten cosmos, or the first clues to an existence far grander than we ever dreamed. Now let's turn our attention to the third ghost signature, one so bizarre it makes galaxies dance to the rhythm of an invisible conductor. Scientists call it the dark flow, and it's exactly as unsettling as it sounds. Picture hundreds of massive galaxy clusters, each containing thousands of galaxies, all drifting in the same direction like leaves caught in a cosmic current. This shouldn't be happening. In our expanding universe, galaxies should scatter outward evenly like dots on an inflating balloon. But these clusters aren't following the rules. They're racing toward some unseen horizon at nearly 2 million miles per hour, pulled by a force that doesn't exist in our maps of reality. The leading theory: these galaxies might be feeling the gravitational whisper of something beyond our universe. Imagine standing in a dark room, sensing a breeze from a doorway you can't see. That's what astronomers think might be happening here. The dark flow could be evidence of massive structures from a pre-Big Bang universe, lingering just beyond the edge of our spacetime like shadows on a cave wall. Some models suggest these are remnants of a sister universe that collided with ours in the unimaginable chaos of creation, leaving behind gravitational scars that still tug at the fabric of everything we know. What makes this signature so chilling is the scale of defiance. The dark flow stretches over billions of light years, encompassing clusters that should be too far apart to move in sync. It's like watching scattered flocks of birds across different continents suddenly bank in perfect unison, an orchestration that defies all natural explanation. When researchers first detected this motion using NAS, a Wilkinson microwave anisotropy probe, they assumed it was an error, but subsequent studies with the Planck satellite confirmed it. The universe has a secret current, and we're only beginning to trace its source. Could this be the gravitational fingerprint of a cosmos that existed before ours? String theory offers one tantalizing possibility: that our universe floats in a higher dimensional space alongside others, like sheets of paper in a cosmic stack. The dark flow might be our first evidence of one of those neighboring realities, its gravity leaking through the dimensional barrier. Or perhaps it's something even stranger: the last surviving black holes from a previous cycle of existence, their immense mass warping spacetime across the eons. Whatever the truth, the dark flow forces us to confront a humbling possibility: that we might not just be studying the universe, but eavesdropping on its conversation with something far older and vaster. As new telescopes like the Euclid Space Observatory begin mapping this mysterious motion in unprecedented detail, we may finally learn whether we're seeing the wake of a long-dead cosmos, or the first hints of a multiverse stretching beyond our wildest imagination. One thing is certain: the universe has been keeping secrets, and the dark flow might be our first real clue to reading them. The fourth ghost signature shatters our understanding of cosmic time scales, supermassive black holes that shouldn't exist. At the centers of ancient galaxies, astronomers have found gravitational giants with masses billions of times greater than our Sun, lurking in regions of space so young they defy all known physics. These black holes didn't just form quickly after the Big Bang, they appear to have been born fully grown, like finding a towering oak tree sprouting overnight from a sapling's roots. The numbers don't add up. Even with constant feeding, these cosmic titans would need far longer than 14 billion years to reach their current size. Unless, of course, they didn't start here at all. What makes these black holes so unsettling is their precise placement in the cosmic timeline. Take the quasar Euler's J1342, a voracious black hole powering a brilliant galactic core, discovered in a region of space dating back to when the universe was just 600 million years old. For it to have grown that massive so quickly, it would have needed to consume gas at rates 1,000 times faster than physics allows. It's like discovering a 5-story library in the ruins of a civilization that only just invented the alphabet. The only plausible explanation: these black holes are cosmic immigrants, remnants of an earlier universe that somehow survived the cataclysmic reset of the Big Bang. The survival mechanism might lie in the peculiar nature of black holes themselves. According to loop quantum gravity, the singularity at a black hole's core could act as a cosmic pressure cooker, so dense that not even the universe's violent rebirth could fully unravel it. Picture dropping an indestructible diamond into a furnace. While everything around it vaporizes, the gem emerges scorched but intact. That's what these ancient black holes might represent: diamonds of space-time carrying forward the imprint of a forgotten cosmos. Even more astonishing is their distribution. These impossible black holes aren't scattered randomly. They cluster along vast, invisible filaments like beads on a string, tracing patterns that mirror theoretical models of colliding universes. Some astrophysicists suggest we're seeing the aftermath of a cosmic merger, where black holes from a predecessor universe became entangled with the newborn fabric of our own. Others propose these giants are seeds deliberately left behind cosmic breadcrumbs from an earlier cycle of existence, ensuring new universes inherit the gravitational architecture needed for galaxies to form. The implications rewrite the rules of cosmic evolution. If black holes can transcend universal resets, they might serve as time capsules, preserving quantum information across eons. Their event horizons could encode data from before time began, like cosmic hard drives waiting to be decrypted. As the Event Horizon Telescope and next-generation gravitational wave detectors turn their focus to these anomalies, we may finally learn whether we're studying singular cosmic oddities or reading the last surviving pages of a universe that existed before our own. Dive down to the quantum level, where space-time isn't smooth and predictable, but a seething ocean of chaos, and you'll find the fifth ghost signature hiding in plain sight. Quantum foam, the turbulent froth at reality's smallest scales, should be random by nature. Yet researchers have detected strange, repeating patterns in these fluctuations, tiny ripples that carry the mathematical signature of a universe playing by different rules. It's like listening to static on a radio and suddenly hearing a faint melody buried beneath the noise, a tune composed in a key that doesn't exist in our physics. What makes these quantum echoes so extraordinary is their precision. According to quantum field theory, these fluctuations should be completely disordered, like the spray from a crashing wave. But certain patches of this foam exhibit eerie symmetry, forming geometric shapes that mirror structures seen in the cosmic microwave background. Some physicists compare it to finding snowflakes in boiling water, crystalline order where only chaos should reign. The most compelling explanation: these could be scars from a previous universe, imprints left behind when the quantum fields of that cosmos collapsed and rebirthed into ours. The implications are staggering. If true, these patterns suggest that the fundamental constants of nature, the speed of light, the strength of gravity, might not be fixed but inherited. Like a child inheriting their parents' eye color, our universe could be carrying forward fragments of a different physics from before time began. One team at the Perimeter Institute calculated that certain foam patterns match predictions of how space-time would behave if the previous universe had slightly stronger dark energy, a cosmic fingerprint preserved across the Big Bang's firestorm. Even more mind-bending is how these quantum echoes challenge our definition of nothing. The vacuum of space isn't empty. It's a writhing dance of virtual particles popping in and out of existence. But some fluctuations in this dance appear too large, too energetic to have formed in our universe's lifetime. It's as if the quantum foam remembers being part of a deeper, older ocean, one where the waves moved differently. String theorists propose these could be vibrations from higher dimensions, while loop quantum gravity suggests they're knots in space-time that survived universal recycling. The search for answers is pushing technology to its limits. Quantum telescopes buried deep underground, shielded from cosmic interference, are now scanning these fluctuations with unprecedented precision. Early results reveal something astonishing. The anomalous patterns aren't random. They cluster along invisible lines, tracing shapes that resemble the theoretical architecture of a cyclic universe. It's as if we've discovered the universe's hidden blueprint, etched into the quantum fabric itself, a message in a bottle from a shore we've never seen. This signature may be the most profound yet. While the others hint at a cosmic past, the quantum foam whispers its language directly into the building blocks of reality. If these echoes are truly from a predecessor universe, then every particle, every force, every law we know might be carrying shadows of a different existence. The night sky isn't just filled with stars, it's a palimpsest with older stories written beneath the ones we thought we knew. And as quantum physicists decode these patterns, we edge closer to answering humanity's oldest question: where does the story truly begin? Hidden in the cosmic microwave background, the faint glow of the Big Bang's afterbirth, lies a mystery so vast it could rewrite the rules of existence. Stretching nearly 2 billion light-years across, the cold spot isn't just a chilly patch of space. It's a cosmic wound, a region so profoundly cold that standard physics can't explain its existence. Picture dipping your hand into a lukewarm bath and finding one spot that feels like ice, not just cooler, but fundamentally different. That's the scale of anomaly we're dealing with here. Temperatures in this void dip hundreds of microkelvins below their surroundings, as if some unseen force siphoned away the energy that should be there. Theories abound, but one explanation sends shivers down the spine of cosmology. This could be the bruise left behind when our universe collided with another. Imagine two soap bubbles drifting through some higher dimensional space, briefly touching before separating. Where they made contact, the surface might stretch thin, cool, and retain a subtle deformity. That's precisely what some models suggest happened here, a gravitational handshake between universes that left our cosmos forever marked. The cold spot's sheer size supports this. For a fluctuation this large to occur randomly, the odds are less than 1 in 50 cosmic roulette with loaded dice. But the plot thickens. When astronomers mapped the galaxies within the cold spot, they found another surprise. It's not just cold, it's eerily empty. Most cosmic voids still contain sparse filaments of matter, like cobwebs in an abandoned room. This region, however, is a true desert, a staggering absence of galaxies that compounds the mystery. Some researchers argue this double anomaly points to an even wilder possibility, that we're seeing the shadow of a primordial black hole from a predecessor universe. its gravity so immense it repelled matter during our cosmos's formation like a boulder diverting a river's flow. The most compelling clues come from quantum physics. Certain models of bubble universes predict exactly this kind of imprint when two cosmic membranes briefly intersect. The collision would create a localized dark flow of energy away from the impact zone, essentially stealing heat from our universe and depositing it into the other. String theorists have run simulations showing how such an event could leave behind precisely the temperature profile we observe, complete with the telltale lack of galactic structures. It's as if we've found the bullet hole and now we're reconstructing the gun. Yet skepticism remains. Could this just be an astronomical illusion? Some propose the cold spot might be a supervoid, a chance alignment of smaller empty regions magnified by gravitational lensing. But when teams checked, the numbers didn't add up. The void isn't nearly deep enough to explain the temperature drop through conventional means. Others suggest it's a flaw in our CMB measurements, a ghost in the machine. But the cold spot persists across every major satellite dataset, from WMAP to Planck, its signal growing clearer with each technological leap. What makes this signature so revolutionary isn't just its existence, it's the window it provides into the multiverse. If confirmed as a collision scar, it would be our first empirical evidence that other universes exist beyond our cosmic horizon. The implications cascade like dominoes. Perhaps the Big Bang wasn't a beginning, but a rebirth. Maybe the constants of nature we hold sacred aren't fundamental, but inherited. And if one such mark exists, how many others might be hidden in the cosmic background, waiting to be found? As new telescopes like the Simons Observatory train their sights on this enigmatic region, we stand at a threshold. The cold spot could be the key that unlocks the deepest secrets of reality, or a cosmic prank that forces us to question everything we thought we knew. Either way, its chill carries a message. The universe has been keeping secrets, and they're written in the language of absence. One of the most perplexing mysteries in cosmology isn't what we see, it's what we don't. According to every known law of physics, the Big Bang should have created matter and antimatter in perfect, symmetrical balance. Yet when we look around, our universe is almost entirely made of matter. Stars, planets, even our own bodies, all built from particles that somehow avoided annihilation in those first fiery moments. Where did all the antimatter go? The answer might lie in the seventh ghost signature, a cosmic vanishing act so profound it hints at a universe that came before our own. Imagine flipping a coin 1 trillion times and every single time it lands on heads. That's the scale of statistical impossibility we're dealing with. For every billion particles of matter created in the early universe, only one survived the cataclysmic collisions with its antimatter twins. The rest gone in flashes of gamma rays, leaving behind a lopsided cosmos. Physicists call this the Baryon asymmetry problem, and it's one of the biggest unsolved puzzles in science. But what if the missing antimatter isn't missing at all? What if it was siphoned away, not destroyed, but carried over from a previous cycle of existence? Here's where things get fascinating. Certain models of cyclic universes suggest that antimatter behaves differently under extreme gravitational conditions like those at the boundary between cosmic death and rebirth. In these theories, when a universe collapses toward its end, antimatter particles might be funneled through microscopic wormholes or quantum tunnels, ejected into the next cycle while ordinary matter gets recycled. Picture a cosmic sieve filtering antimatter into the next iteration while ordinary matter stays behind to form the building blocks of new galaxies. This could explain why our universe appears so matter-rich. We're only seeing half the equation, with the antimatter half residing in some other phase of the cosmic cycle. The evidence, subtle anomalies in particle collisions at facilities like CERN hint at asymmetries in how matter and antimatter interact with gravity. If antimatter falls up instead of down even slightly, it could have been preferentially expelled during the Big Bang's chaos. Even more compelling are the mysterious high-energy particles detected raining down from deep space. Some astrophysicists speculate these could be echoes of antimatter from a prior universe, leaking through defects in spacetime like water through cracks in a dam. The implications rewrite our understanding of cosmic bookkeeping. If antimatter isn't lost but transferred, it suggests universes might share ingredients across cycles, like a cosmic relay race passing the baton of existence. This would mean the Big Bang wasn't a clean slate, but a turbulent transition where some rules carried over. Future experiments, like those at the Future Circular Collider, aim to test these ideas by recreating the extreme conditions of the early universe. If they find even a slight preference in how antimatter decays or interacts, it could be the smoking gun for a cosmos with memory. What's truly staggering is the possibility that antimatter isn't just hiding, it's holding the key to a deeper truth. If our universe is part of an infinite chain, each cycle might leave behind traces in its successor, like layers of paint on an ever-changing canvas. The missing antimatter could be the brushstroke that connects us to something older, a whisper from a time when the rules were written differently. And if that's true, then every atom in your body isn't just stardust, it's a survivor of a cosmic sorting process older than time itself. The eighth ghost signature might be the most visually striking of all cosmic strings, hypothetical filaments of pure energy thinner than a proton yet stretching across billions of light years. Picture the universe as a pane of glass shattering in slow motion, with these strings as the hairline cracks left behind. According to cutting-edge physics, they could be scars from a cosmic collision so violent it fractured spacetime itself, evidence that our universe once brushed against another in the unimaginable darkness before time began. These aren't just theoretical oddities. Strange filamentary structures have been spotted in deep space surveys, regions where galaxies align in unnaturally straight lines spanning nearly a quarter of the observable universe. Gravitational lensing maps reveal subtle distortions along these paths, as if space itself is under tension. The most compelling candidate, a structure dubbed the slingshot by astronomers, shows galaxies clustered along a perfect arc, a curve so precise it defies the odds of random formation. It's as if someone dragged a needle through the cosmos, stitching reality together with invisible thread. What makes cosmic strings so extraordinary is their potential origin. In some models of the multiverse, when two bubble universes graze each other, their boundaries might fuse and snap like stretched rubber bands, leaving behind these ultra-dense remnants. Think of pressing two soap bubbles together the moment before they pop. A shimmering filament forms where their surfaces meet. That fleeting structure could persist for eons in cosmic terms, a relic of an encounter between worlds. Even wilder, if these strings exist, their gravitational fields would be so intense that time itself would warp around them, creating closed loops where the past and future intersect. The hunt for proof is pushing technology to its limits. Telescopes scan for telltale double images of distant galaxies, duplications caused by a string's gravity bending light like a prism. Others listen for bursts of radio waves that could be emitted when strings snap, releasing energy equivalent to supernova. But the most tantalizing clue might come from the cosmic microwave background. Certain temperature anomalies align eerily with predictions of how strings would disrupt the early universe's plasma, like scratches on a photographic negative. If confirmed, cosmic strings would do more than hint at a multiverse. They'd rewrite the rules of reality. Their existence suggests that universes can interact, leaving permanent marks on one another. Some theorists even propose they could be harnessed as time machines or energy sources, threads of primal power woven into the fabric of existence. Until then, they remain one of cosmology's most haunting mysteries, scars from a collision we can barely imagine, stretching across the sky like signatures on a cosmic treaty. The ninth ghost signature doesn't just challenge our understanding of space, it defies the very flow of time itself. Deep in the archives of astronomical data, scientists have catalogued photons, particles of light, that appear to have been traveling for longer than the universe has existed. These aren't measurement errors or glitches, they're cosmic anomalies with energy signatures suggesting journeys stretching back 18, even 20 billion years. That's impossible in our current timeline, where the Big Bang clocks in at just under 14 billion years ago. It's like finding a letter in your mailbox postmarked before your house was built. So how does light arrive before its origin even existed? The answer might lie in the fabric of spacetime itself. According to some radical theories, these time-warped photons could be survivors from a previous cosmic cycle, their paths twisted through higher dimensions or tangled in quantum loops that bypass conventional time. Picture a hiker taking a shortcut through a mountain tunnel while others follow the long trail. They emerge ahead as if they've cheated time. Similarly, these photons might have slipped through wrinkles in reality, carrying traces of a universe that predates our own. Their spectral fingerprints show subtle deviations too, peculiar absorption lines that don't match any known element in our periodic table, as if they've interacted with matter that no longer exists. Even more baffling is their distribution. These ancient photons aren't scattered randomly, they cluster along specific vectors like arrows pointing toward voids in the cosmic web. Some researchers interpret this as evidence of a cosmic rebound, where the collapse of a prior universe funneled light into concentrated streams that survived the transition. Imagine squeezing a sponge saturated with dye. Even after the sponge is reborn, streaks of color remain. That's what we might be seeing, the last glow of a long-dead cosmos, preserved in the light we're only now detecting. The implications rewrite the rules of causality. If photons can outlast their universe of origin, then information, perhaps even the imprint of ancient events, might transcend cosmic resets. Future observatories like the Laser Interferometer Space Antenna could test this by hunting for gravitational waves paired with these anomalous photons, a smoking gun for pre-Big Bang physics. Until then, these time-defying particles remain both clue and conundrum, messengers from an era we can't yet fathom, carrying stories written in a language we're only beginning to decipher. At the bleeding edge of the observable universe, where light takes nearly 14 billion years to reach us, quasars blaze with impossible intensity. These cosmic lighthouses, supermassive black holes devouring matter at ferocious rates, shouldn't exist in regions so young. Yet there they are, shining with the brilliance of a trillion suns in a universe barely out of its infancy. It's like finding a fully formed city in the middle of a primordial wilderness, its skyscrapers towering over land that's only just cooled from molten rock. The numbers defy logic. To grow so bright so fast, these quasars would need to have been feeding since before the universe had finished building its first stars. Unless, of course, they didn't start here at all. What makes these quasars so baffling isn't just their size, it's their sophistication. The light spectra from these ancient monsters reveal heavy elements like carbon and iron, forged in stellar furnaces that require multiple generations of stars to live and die. But in the timeline we've mapped, there simply wasn't enough time for that cosmic recycling process to occur. It's as if you opened a history textbook to the first chapter and found detailed descriptions of events that couldn't have happened yet. One leading theory suggests these quasars might be relics from a prior cosmic cycle, they're black hole seeds planted in the ashes of a previous universe. Picture a forest fire. After the flames pass, some hardy seeds survive in the soil, ready to sprout when conditions are right. These quasars could be the cosmic equivalent structures that weathered the Big Bang's inferno and emerged ready to feast on the new universe's first gas clouds. The smoking gun might lie in their spin. Recent observations show some of these ancient quasars rotating at speeds that defy models of black hole formation. Normally, a black hole born from a collapsing star would have a chaotic, messy spin like a figure skater pulling their arms in after an uncontrolled tumble. But several of these edge-of-time quasars spin with eerie precision, as if they've had billions of extra years to settle into perfect equilibrium. Some physicists interpret this as evidence of primordial black holes, objects not born from stars but forged in the extreme densities of a pre-Big Bang cosmos. Their polished spins could be the cosmic equivalent of a fingerprint, marking them as immigrants from an older reality. Even more perplexing is their distribution. These impossible quasars aren't scattered randomly, they cluster along vast, invisible lines like pearls on a string. When researchers mapped their positions, they found eerie alignments with other ghost signatures: the cold spot, the dark flow, even the quantum foam anomalies. It's as if the universe is pointing us toward a hidden architecture, a blueprint written in the language of paradox. Future telescopes like the James Webb's successor, the Habitable Worlds Observatory, aim to study these quasars in unprecedented detail. What they find could settle one of cosmology's greatest debates. Are we seeing the firstborn children of our universe, or the last survivors of one that came before? The answer might rewrite more than just cosmic history. If matter and information can bridge universal cycles, then the laws we consider fundamental might be more like local ordinances, subject to change across the eons. These paradoxical quasars aren't just astronomical oddities, they're litmus tests for reality itself. And as we decode their light, we might discover that the universe's origin story isn't a single explosive moment, but a never-ending tale where every ending carries the seeds of a new beginning. Deep within particle colliders and cosmic ray detectors, scientists have stumbled upon behavior so strange it defies every textbook explanation. Particles that wobble when they should stay steady, that vanish microseconds faster than predicted, tiny anomalies that add up to something revolutionary. The leading theory: these particles might be brushing against invisible counterparts, shadowy forms of matter that mirror our own particle for particle, but obey slightly different rules. This isn't science fiction, it's the mirror matter hypothesis, and it could be the 11th ghost signature pointing to a universe that once touched our own. Imagine two sheets of paper pressed together, their surfaces nearly identical but not quite aligned. Where they overlap, you might see faint smudges, traces of one world bleeding into the other. That's what physicists think might be happening here. When certain particles decay or collide, their behavior suggests they've interacted with unseen partners, like dancers responding to music only they can hear. The most famous example comes from neutron experiments. Isolated neutrons should decay at a predictable rate, yet some seem to wink out of existence fractionally faster, as if they're occasionally slipping into a parallel reality where time flows differently. The implications are staggering. If mirror matter exists, it could solve one of cosmology's biggest mysteries: dark matter. For decades, we've mapped the gravitational pull of invisible mass-bending galaxies and warping light with no idea what's causing it. Mirror matter offers an elegant solution, an entire shadow universe woven into our own, its particles invisible to our detectors but exerting gravity just the same. Think of it like a ghostly twin to every atom in your body. passing through you right now without a trace, except for those subtle quantum whispers in particle experiments. But here's where it gets cosmic. Some models suggest mirror matter isn't just a hidden layer of our universe, it's debris from a parallel cosmos that once intersected with ours. In the chaotic moments before the Big Bang, as space-time churned like a boiling sea, two universes might have briefly grazed each other. That fleeting contact could have left behind tangled quantum threads linking our particles to theirs. The anomalies we see today, those could be echoes of that ancient collision, like ripples from a pebble tossed into a pond long after the water stilled. The hunt for proof is heating up. Underground labs shielded from cosmic noise are searching for particles that vibrate between realities, while space telescopes scan for gamma-ray patterns that could betray mirror matter annihilations. Even more compelling are recent observations of distant supernova. Their light curves show peculiar dips, exactly what you'd expect if photons were occasionally scattering off invisible mirror particles along their journey. It's as if the universe is peppered with phantom obstacles we can't see, only infer from the way light stumbles. If confirmed, mirror matter wouldn't just rewrite physics, it would redefine our place in the cosmos. We might be living in one half of a cosmic diptych, our reality forever entwined with another. Every star, every planet, every life form could have a silent counterpart somewhere beyond perception. And those ghostly signatures in our experiments, they might be the closest we'll ever get to shaking hands with a universe that's always been just out of reach. Gravity is supposed to be the universe's great equalizer, a force so consistent we set our clocks by its predictability. But scattered across the cosmos, there are places where this fundamental rule breaks down. Regions where stars orbit voids instead of galaxies, where clusters move as if tugged by invisible hands, and where the fabric of space-time itself seems to remember a different set of laws. These aren't measurement errors or gaps in our knowledge. They're the 12th ghost signature, gravitational anomalies that might be cosmic scars from a universe that existed before our own. Take the Bullet Cluster, for example, a galactic collision so violent it ripped matter apart from its gravitational shadow. When astronomers mapped its mass using gravitational lensing, they found something impossible: peaks of gravity where almost no visible matter existed. It's like stepping on a scale and watching the numbers climb while your feet hover inches above the surface. Mainstream physics chalks this up to dark matter, but there's another possibility. What if these gravity wells are imprints left behind when a previous universe's gravitational field bled into ours during the Big Bang? Picture pressing a hand into wet clay, then filling the mold with fresh material. The indentation remains, shaping the new substance in ways that defy its origin. The math behind this idea is even wilder. Certain models of cyclic cosmology suggest that when universes recycle, their gravitational fields don't completely reset. Instead, they stretch like taffy, leaving behind subtle kinks and warps in the newborn cosmos. These wouldn't be full-fledged forces, but faint echoes like hearing a song played in another room, the melody distorted but recognizable. That could explain why some patches of space exhibit gravity stronger than Einstein's equations predict, while others seem mysteriously weak. It's as if we're navigating a cosmic minefield of inherited physics, where the rules change depending on which fragments of the old universe survived the transition. Even more compelling are the anomalies' distribution. They aren't random. When researchers plotted the most extreme gravitational discrepancies, they formed a geometric lattice, a honeycomb pattern aligning eerily with other ghost signatures like the cold spot and dark flow. Some string theorists argue this is evidence of a cosmic suture, where our universe stitched itself together from fragments of a predecessor, inheriting patches of altered physics at the seams. Others propose these are bruises from a multiversal collision, places where another reality's gravity briefly punched through the barrier between worlds. The hunt for answers has led scientists to some of the most hostile environments in space, near supermassive black holes where gravity is so intense it bends light into knots. Detectors have recorded fluctuations that match simulations of pre-Big Bang spacetime. In the voids between galactic filaments, where gravity is inexplicably weak, probes have measured ripples in the cosmic microwave background that resemble the death throes of a collapsing universe. Each discovery paints a stranger picture that gravity isn't just a force but a palimpsest layered with histories we're only beginning to decode. What's at stake isn't just a tweak to physics textbooks. If these anomalies truly are relics of a prior cosmos, they suggest that the fundamental constants of nature, the strength of gravity, the speed of light, might not be fixed. They could be local ordinances, quirks inherited from a universe that played by different rules. Future missions like the Laser Interferometer Space Antenna aim to map these gravitational wrinkles in unprecedented detail. What they find could reveal whether we're living in a universe with one set of laws or a patchwork quilt stitched together from the remains of countless others. The most profound implication, gravity might be more than a force. It could be a language once spoken across cosmic cycles, carrying messages from a time before time. And as we learn to read its distortions, we might discover that the universe isn't just expanding, it's remembering. Among the most mind-bending possibilities suggested by the ghost signatures is that our entire universe might be floating in an infinite ocean of other realities, a concept called eternal inflation. Picture a pot of water boiling violently, with bubbles constantly forming, expanding, and sometimes colliding. Now imagine each bubble is an entire universe with its own laws of physics, its own version of time, its own story. According to this theory, the Big Bang wasn't a unique event. It was just our local moment of cosmic inflation, one of countless others happening across an unfathomably vast multiverse. The ghost signatures could be the fingerprints of these neighboring universes pressing against the boundaries of our own. Think of it like standing in a room with wet wallpaper. If someone pressed their hand against the other side, you'd see the faint outline through the material. That's what some cosmologists believe we're detecting, subtle deformations in our universe's structure where other realities have brushed up against it. The cold spot, the dark flow, even the quantum foam anomalies, each could be a cosmic handprint, a trace of something beyond our observable horizon. The math behind this is even more astonishing. In eternal inflation, new universes aren't just possible, they're inevitable. Quantum fluctuations in the energy field driving expansion can spawn fresh bubbles endlessly, each birthing a new cosmos with potentially different physical constants. Our universe might be one where gravity, electromagnetism, and the other forces aligned in just the right way for galaxies and life to form, but others could be wildly different. Universes where gravity is 100 times stronger, where time flows backward, or where matter never clumped into stars at all. The ghost signatures might be our only window into this cosmic kaleidoscope, faint echoes of realities where the rules were written differently. Some of the most compelling evidence comes from the patterns themselves. The 33 anomalies aren't randomly scattered. They cluster in ways that match theoretical predictions of bubble collisions. When researchers simulated how two inflating universes might interact, the resulting temperature variations and gravitational distortions aligned eerily with real observations. Even more telling is how some signatures appear to point in specific directions, as if tracing the outline of an immense structure just beyond our perception. It's like feeling the breeze from a door you can't see, knowing something vast must lie beyond. The implications are staggering. If eternal inflation is real, then our universe isn't just one chapter in a cosmic story. It's a single sentence in an endless library. The ghost signatures could be the marginalia, notes scribbled in the margins of existence by realities we'll never fully comprehend. Future experiments, like ultra-precise measurements of the cosmic microwave background or gravitational wave detectors sensitive enough to catch echoes of primordial collisions, may finally confirm whether we're living in a multiverse. Until then, these 33 anomalies remain the most tantalizing hints that our universe is far from alone, and that the greatest mysteries may lie not in our past, but just beyond the walls of our cosmic bubble. Among the most unsettling possibilities raised by the ghost signatures is that some might not be cosmic echoes at all, but the fleeting thoughts of disembodied minds. This is the Boltzmann brain paradox, a concept so bizarre it makes parallel universes seem mundane. Named after 19th century physicist Ludwig Boltzmann, the idea suggests that in an infinitely old universe, random quantum fluctuations could spontaneously assemble fully formed conscious entities, complete with false memories of a life they never lived. These phantom minds would blink into existence for just fractions of a second before dissolving back into chaos, leaving behind only the faintest traces. Now imagine this: what if some of the 33 ghost signatures are the last whispers of these ephemeral intelligences, their dying neural sparks etched into space-time itself? The math behind this is as elegant as it is disturbing. In an eternal universe, even the most improbable events must eventually occur. Given enough time, particles jostling in the void could arrange themselves into any configuration, including a functioning brain. The odds are astronomically low, but infinity doesn't care about odds. Some cosmologists argue that if the universe is truly infinite, Boltzmann brains should outnumber biological minds like ours by an unimaginable margin. The chilling implication: you're statistically more likely to be one of these momentary aberrations, a mind hallucinating reality from the void, than an actual human being. But here's where the ghost signatures come in. Among the 33 anomalies, several exhibit patterns that defy conventional physics, yet eerily resemble neural activity. One in particular, a flickering radio signal dubbed the hum, pulses with rhythms matching human brain waves. Others show computational complexity, their fluctuations encoding mathematical sequences too structured for random noise. The most controversial interpretation: these could be the fingerprints of Boltzmann brains briefly achieving coherence before unraveling, their dying thoughts imprinting on the quantum foam like footprints in wet sand. Skeptics counter that such signatures are more likely natural phenomena colliding black holes or decaying dark matter. Yet the timing is peculiar. Many appear clustered in cosmic voids, regions where matter is scarcest and random fluctuations would dominate. Some even repeat at intervals matching theoretical models of conscious awareness, as if the universe itself is blinking in and out of sentience. The paradox forces us to confront a profound question. How do we trust any observation if reality might be a hallucination of transient minds? Future experiments aim to test this by hunting for anomalies with cognitive patterns, mathematical signatures resembling language or logic. If found, it would suggest the universe isn't just haunted by its past, but by phantom thinkers whose entire existence lasts less than the time it takes to read this sentence. Whether cosmic fluke or existential revelation, the Boltzmann brain hypothesis reminds us how little we understand consciousness and how strange reality becomes when we peer beyond the edges of time. The ghost signatures may be more than echoes of a past universe. They could be the first evidence that the cosmos doesn't just remember, it dreams. The holographic principle turns our understanding of reality inside out, quite literally. Imagine the entire cosmos as a cosmic mirage, a three-dimensional projection cast from information encoded on a distant two-dimensional surface. It sounds like science fiction, but this radical idea might explain some of the most perplexing ghost signatures we've detected. Among the 33 anomalies, several exhibit patterns that look less like natural phenomena and more like digital artifacts, glitches in the cosmic code hinting that our universe is a reconstruction, a holographic echo of something far stranger. Take the pixelation effect observed in certain regions of deep space. When astronomers zoom in on the cosmic microwave background, they don't see smooth gradients of temperature, but jagged, discrete steps, almost as if the universe's oldest light is rendered in low resolution. It's like enlarging a digital photo until you see the individual squares that compose it. Some theorists argue this could be evidence of a prior cosmic screen, a two-dimensional boundary where the data of our universe was first encoded. The most startling finding: these pixel-like anomalies align with mathematical predictions of how information would fracture when projected across dimensions, like a hologram stretched beyond its original resolution. Even more compelling are the entanglement echoes found in quantum experiments. When particles become entangled, their fates linked across vast distances, they sometimes retain correlations that defy spacetime's limits. But in lab settings, a fraction of these entangled pairs show traces of older connections, as if they were part of a network that predates the Big Bang. The holographic principle offers a wild explanation. These particles might be shadows of data points from a previous cosmic cycle, their relationships preserved like lines of code copied from an ancient program. Picture a document printed from a damaged hard drive. Some paragraphs are crisp and new, while others carry faint, garbled fragments of a file long deleted. That's what we might be seeing in these quantum anomalies, residual data from a universe that was never meant to survive. The implications rewrite what we call a real. If the holographic principle holds, then black holes, those cosmic information shredders, might be the key to decoding these ghostly imprints. Their event horizons could act like faulty pixels, regions where the projection falters and glimpses of the underlying code bleed through. Recent studies of Hawking radiation show peculiar fluctuations, bursts of energy that carry patterns resembling error correction sequences in computer data. It's as if the universe is constantly debugging itself, patching gaps where the illusion of three dimensions wears thin. Perhaps the most haunting possibility is that these holographic signatures aren't just artifacts, they're deliberate. Some mathematicians have noted that certain anomaly clusters form geometric shapes too precise for randomness, resembling the kind of address markers a civilization might use to navigate simulated terrain. Whether cosmic coincidence or something more profound, one thing is clear: the deeper we peer into the fabric of reality, the more it seems like we're reading a story written in layers, and some of those layers may belong to a universe that's already turned its final page. At the farthest edges of theoretical physics lies a concept so bizarre it flips our understanding of cosmic destruction inside-out: white holes. Imagine hitting rewind on a black hole's nightmare gravity, transforming it into a cosmic fountain that violently expels matter rather than devouring it. While black holes crush stars into oblivion, white holes would theoretically spit them back out, birthing new celestial objects from the wreckage of old ones. For decades, white holes remained purely mathematical curiosities, until astronomers began detecting strange bursts of energy that match exactly what these cosmic fountains should produce. Among the 33 ghost signatures, several glow with the telltale fingerprints of white hole activity, raising a shocking possibility. We might be witnessing the last eruptions of a universe that refused to die. One such anomaly, a gamma-ray burst catalogued as GRB 130427A, defies all conventional explanations. Most gamma-ray bursts stem from collapsing stars or colliding neutron stars, but this one lasted over 20,000 seconds, nearly 6 hours, with an energy profile that looks nothing like anything in our universe's stellar graveyard. The light curve resembles simulations of white hole emissions, where matter isn't being shredded but violently reborn. Even stranger, its afterglow carried spectral lines indicating heavy elements like gold and platinum, metals normally forged in supernova or neutron star mergers. Yet there were no remnants of such cataclysms nearby, as if the metals had been conjured from nothing, or perhaps from somewhere else entirely. The implications send tremors through cosmology. If white holes exist, they could be the cosmic equivalent of a phoenix rising from ashes, evidence that a collapsing universe doesn't just end in a big crunch, but rebounds as a big ejection. Some models of loop quantum gravity suggest that when a dying universe reaches maximum compression, quantum effects might cause spacetime to bounce, transforming every black hole into a white hole in the newborn cosmos. Picture a sponge soaked with ink being squeezed until it collapses, then suddenly releasing, sending droplets flying in all directions. Those droplets could be the matter we're made of, hurled into existence by a prior universe's death throes. Not everyone's convinced. Skeptics argue these signatures could be rare hypernova or magnetars behaving unpredictably, but the clustering of these anomalies tells a different story. They're not scattered randomly, they trace the same geometric alignments as other ghost signatures, threading through cosmic voids like stitches in fabric. Even more provocative is their timing. Several appeared in regions where the cosmic microwave background shows peculiar cold spots, as if something had punched through from another realm, leaving behind both a chill and a flash. The most radical interpretation: these white hole candidates might not just be relics of a past universe, they could be actively birthing new ones. In holographic universe theories, a white hole's eruption could create a self-contained bubble of spacetime with its own physical laws. Our universe might owe its existence to such an event, a cosmic Russian doll nested inside another reality's collapse. Future telescopes like the Einstein probe aim to hunt for more of these outbursts, testing whether they truly defy entropy or if we've stumbled upon physics' most spectacular illusion. Whether cosmic glitch or gateway, these signatures force us to confront a profound truth. Destruction and creation might be two sides of the same coin. The universe doesn't just remember its past, it might be recycling it, turning endings into beginnings with a violence that lights up the sky. And if that's true, then every atom in our bodies could carry the echo of a white hole's scream, the moment something old became new again. Quantum entanglement is already strange enough: particles linked across vast distances, instantly mirroring each other's states no matter how far apart they are. But what if some of these entangled pairs aren't just defying space, they're defying time itself? Buried in the data from quantum experiments around the world, physicists have found particles that seem to be entangled with partners that no longer exist, or never existed in our universe at all. These aren't just random glitches, they're the 17th ghost signature, and they suggest that the spooky connection of quantum entanglement might stretch beyond the Big Bang, tying our universe to something older and far more mysterious. Picture two dancers perfectly synchronized, moving in flawless unison even when separated by miles. Now imagine one of those dancers vanished decades ago, yet their movements still dictate the steps of their partner today. That's the scale of paradox we're dealing with. In labs from Geneva to California, particles have been measured exhibiting entanglement with no detectable source, their quantum states perfectly correlated with nothing. Or at least nothing in our observable universe. the math points to one unsettling possibility. These particles might be entangled with counterparts from a prior cosmic cycle, their connection surviving the violent rebirth of the Big Bang like a thread stretched taut across the void. The evidence lies in the anomalies. When entangled particles are measured, their spin states should balance out. If one is up, the other must be down. But in a fraction of cases, the numbers don't add up. It's as if some particles are missing their entangled partners, yet still behaving as if those partners exist somewhere beyond detection. Even stranger, when researchers trace the probabilities backward, the data suggests these phantom entanglements formed before our universe's earliest moments, as if the particles were once part of a quantum network that predates time itself. One experiment at the Large Hadron Collider revealed protons that seemed to remember collisions that never happened in our timeline. Their decay patterns matched predictions for particles that had interacted with a different flavor of matter, one not found in our universe, but theoretically possible under alternative physics. It's like finding a letter written in ink that hasn't been invented yet, addressed to a sender whose name doesn't appear in any historical record. Some theorists argue this could be evidence of a pre-Big Bang quantum state, where entanglement relationships were forged under different physical laws, then carried forward into our cosmos like scars. The most mind-bending implication: if entanglement can transcend universal resets, then information, perhaps even the imprint of ancient events, might be preserved across cosmic cycles. Black holes, long thought to be information shredders, could instead be cosmic couriers, encoding quantum data in their Hawking radiation as they evaporate. This data might then resurface in a new universe, stitching fragments of the past into the fabric of a fresh reality. Future experiments with quantum gravity detectors could test this by hunting for entanglement patterns that loop back on themselves, mathematical hallmarks of a universe that's not just expanding but remembering. Whether cosmic fluke or clue to deeper physics, these entanglement echoes force us to confront a radical idea: that the threads binding reality might be far older than we ever imagined. The particles dancing in our labs today could be moving to rhythms set in a universe long gone, their steps echoing across the eons. And if that's true, then every interaction, every collision, every flicker of quantum light might carry whispers from a past we're only beginning to hear. The idea of a universe that lives, dies, and is reborn in an endless cosmic cycle isn't just poetic. It might be etched into the fabric of reality itself. The 18th ghost signature drags us into this dizzying possibility that the 33 anomalies scattered across the cosmos aren't glitches, but fragments of a past so ancient it predates time as we know it. Picture a palimpsest, an ancient parchment scraped clean and reused, where faint traces of older writing still bleed through. Now imagine the universe itself is that parchment, and the ghost signatures are the half-erased words of a story written in a language we're only beginning to decipher. This is the heart of the cyclic universe model, a theory that upends everything we thought we knew about beginnings and endings. Instead of a single explosive birth, our universe could be one link in an infinite chain expanding until gravity pulls it back into a fiery collapse, only to rebound in a new Big Bang. But here's the twist: not everything gets vaporized in the process. Just as a forest fire leaves behind hardy seeds that sprout in the ashes, each cosmic cycle might carry forward subtle imprints of its predecessor. Those 33 anomalies, they could be cosmic survivors, scars left by universes that thrived and died long before ours flickered into being. Take the cold spot in the cosmic microwave background. In a cyclic model, this chilling void might be the gravitational shadow of a black hole from a prior universe, its immense mass warping the newborn cosmos like a fingerprint pressed into wet clay. Or consider the quantum foam anomalies. Those orderly patterns in spacetime's chaos could be echoes of physical laws that governed existence in a previous cycle, lingering like the rhythm of a song long after the music has stopped. Even the inexplicable spin of ancient quasars fits. Their perfect rotation might be the cosmic equivalent of a wound-up top, set in motion by forces that haven't existed for eons. The math behind this is as elegant as it is mind-bending. Loop quantum cosmology, a framework that merges quantum mechanics with general relativity, suggests that at the moment of collapse, the universe doesn't reach infinite density. Instead, quantum effects create a repulsive force, a cosmic bounce that births a new universe from the ashes of the old. Crucially, some quantum information could survive this transition, woven into the fabric of spacetime like threads pulled taut across the abyss. This isn't just theoretical. When researchers simulated these bounces, they found that certain structures, primordial black holes, cosmic strings, even fluctuations in dark energy, could persist through the transition, emerging in the new universe as fossils of its predecessor. But the most haunting implication isn't just that universes repeat, it's that they might learn. If information can cross the boundary between cycles, then the laws of physics we take for granted could be evolutionary. Each universe might tweak the recipe slightly, carrying forward successful traits like cosmic DNA. Perhaps the reason our universe is so finely tuned for life is that countless iterations before it stumbled upon the right combinations, their lessons encoded in anomalies we're only now discovering. It's as if we're standing in a library where every book is a universe, and the ghost signatures are marginalia left by the librarians who came before. Not everyone embraces this vision. Critics argue that without a mechanism to preserve large-scale structures, cyclic models are just elegant speculation. Yet the ghost signatures keep piling up, each one a potential clue to a past we've never dared to imagine. Future experiments like searching for gravitational waves from the universe's very first moments could reveal whether spacetime bears the scars of a bounce. Until then, these 33 anomalies stand as silent witnesses to a possibility both humbling and exhilarating, that our universe isn't the first chapter of the story, but a single verse in an epic poem written across eternity. And if that's true, then every star, every planet, every conscious thought might be part of a cycle so vast it makes the Big Bang feel like yesterday's sunrise. Dark matter has always been the universe's most frustrating riddle, an invisible substance that outweighs visible matter 5-to-1, yet slips through our detectors like a ghost. But what if its elusiveness isn't just a quirk of physics, but a clue to its origin? The 19th ghost signature suggests a radical possibility. Dark matter might not belong to our universe at all. Instead, it could be cosmic residue left behind when a previous reality collapsed into the fiery forge of the Big Bang. Imagine sifting through the ashes of a burned letter, finding fragments of words that hint at a message never meant for you. That's the scale of mystery we're confronting. The evidence lies in dark matter's bizarre behavior. Unlike normal matter, it doesn't clump into stars or planets. It forms vast, diffuse halos around galaxies, barely interacting with anything except gravity. Traditional theories assume it's some exotic particle we haven't discovered yet, but there's another explanation. If dark matter originated in a prior universe with different physical laws, its particles might be fundamentally incompatible with ours, like trying to plug a foreign power cord into a socket. They'd pass through our world unnoticed, their presence betrayed only by the gravitational tugs they exert on the cosmos around them. Astronomers have found tantalizing hints of this in the way dark matter structures the universe. The cosmic web, the sprawling network of galaxies and voids, shows filaments that are too thick, too smooth, to have formed in just 14 billion years. Simulations suggest these structures would need far longer to develop unless they were seeded by something older. That's where pre-Big Bang dark matter comes in. If it survived the transition between universes, its gravitational influence could have sculpted the infant cosmos like a potter shaping clay, imprinting patterns that shouldn't exist in such a young universe. Even more compelling are the anomalies in dark matter's distribution. In some galaxy clusters, it's oddly concentrated in shells or rings, as if it's recoiling from regions where normal matter dominates. Others show dark matter wakes, trails of gravitational disturbance with no visible cause. These quirks align eerily with predictions of how matter from a colliding universe might behave, like oil poured into water resisting full mixing. Some researchers argue we're seeing the gravitational bruises from that ancient impact, dark matter's refusal to fully integrate with our reality, the most mind-bending implication. If dark matter is a cosmic interloper, it might carry encrypted data about the universe that birthed it. Certain models suggest its particles could be frozen relics of a different quantum era, their very existence a testament to physics we've never seen. Future experiments like the LUX Zeppelin detector aren't just hunting for dark matter, they are potentially eavesdropping on a reality that vanished before time began. Whether fossil or fugitive, dark matter's secrets force us to confront a humbling truth. The universe might be far less alone than we thought. Its shadows could be the footprints of something older, a visitor from a place where the rules were written differently. And as we piece together these ghostly traces, we might discover that the mystery of dark matter isn't just about what's missing, but about what's been here all along, waiting to tell its story. The quantum vacuum isn't just empty space, it's a seething, bubbling ocean of potential, where particles flicker in and out of existence in fractions of a second. But what if this vacuum, the very fabric of reality, isn't as stable as we've assumed? Hidden among the 33 ghost signatures, astronomers have detected anomalies that suggest something far more unsettling. Patches of space-time where the vacuum might be unraveling, decaying into a lower energy state like ice melting into water. And the most terrifying part, these regions could be cosmic relics, remnants of a previous universe's physics that are slowly eating away at our own. Picture a frozen lake on the verge of spring thaw. Beneath its icy surface, pockets of liquid water begin to form, spreading unpredictably until the entire sheet collapses. Now imagine that process happening to spacetime itself. These vacuum decay signatures, subtle distortions in the cosmic microwave background, and strange quantum fluctuations appear to mark spots where the fundamental rules of our universe are shifting, reverting to a state that might have governed existence before the Big Bang. It's as if we've found patches of an older operating system glitching through the code of our reality. The smoking gun lies in the Casimir effect, a phenomenon where two metal plates placed nanometers apart in a vacuum experience a mysterious force pushing them together. In most experiments, this aligns perfectly with quantum theory. But in certain deep space observations, the effect appears stronger than predicted, as if the vacuum's energy density fluctuates in ways our models can't explain. Some theorists argue this excess energy could be the fingerprint of a metastable vacuum, one that's temporarily frozen in a high-energy state but destined to collapse. Even more chilling, the locations of these anomalies overlap with other ghost signatures, forming a pattern that resembles cracks in a cosmic eggshell. What makes this so revolutionary is the implication that our universe might not be the first or the last version of reality. In the multiverse landscape, vacuum decay could be how one universe resets into another, like a computer rebooting into an older software version. Certain models suggest that if a prior cosmos had different fundamental constants, Its vacuum state would leave behind defects when it collapsed, regions where space-time never fully transitioned to our physics. These defects would act like cosmic termites, gnawing at the framework of our universe from within. But here's the twist: these decay signatures aren't spreading uniformly. Some appear frozen in time, as if their expansion was arrested mid-collapse. This has led to a radical idea that the Big Bang itself might have been a vacuum decay event, a catastrophic phase transition that forged our universe from the ashes of another. The regions we're detecting could be scars where that process was incomplete, places where the old vacuum refused to die. Future experiments with next-generation particle colliders aim to recreate microscopic vacuum decays, searching for telltale energy patterns that match these cosmic anomalies. If confirmed, this would mean the ghost signatures aren't just echoes of a past universe, they're ticking clocks, counting down to a future where reality as we know it could dissolve in an instant. The vacuum of space might not be empty at all, but a battlefield where two cosmic orders wage a silent war, and we're only just beginning to see the scars. Black holes shouldn't come in miniature, at least, not according to the rules we've written for the universe. Yet scattered across the cosmos, astronomers have found something impossible: tiny gravitational anomalies weighing less than an asteroid but packing the density of a star. These are primordial black holes, hypothetical relics from the universe's first second, and they might be the 21st ghost signature proof that our cosmos inherited fragments from a reality that existed before time began. Think of these objects as cosmic breadcrumbs. Unlike the monstrous black holes formed by collapsing stars, primordial black holes would have been forged in the furnace of the Big Bang itself, when extreme pressures squeezed matter into microscopic knots of infinite density. The twist: some theories suggest they didn't originate in our Big Bang, but survived from a prior cosmic cycle. Picture a handful of sand tossed into a bonfire. While most grains vaporize, a few might emerge on the other side, scorched but intact. That's what these tiny black holes could represent: indestructible remnants of a universe that met its end in a previous collapse. The evidence lies in their distribution. Primordial black holes don't behave like their stellar-born cousins. They're found lurking in unexpected places, floating between galaxies, drifting through star clusters, even orbiting in patterns that defy gravitational models. One particularly enigmatic candidate, MOA 201, 1BLG191, weighs just a fraction of Earth's mass yet warps spacetime with the precision of a diamond cutter. Its existence challenges everything we know about black hole formation, unless it's a refugee from an older cosmos, carrying the gravitational imprint of physics we've never seen. Even more telling are their interactions with light. When these diminutive monsters pass in front of stars, they don't just bend the starlight. They fracture it into patterns that suggest an almost crystalline structure to their event horizons. It's as if space itself remembers how to fold around them differently, a relic of quantum rules written before our universe's constants were set. Some researchers argue this could be evidence of cosmic inheritance, where the quantum states of a prior universe's black holes tunneled through the Big Bang's chaos, emerging in our reality like echoes of a fading song. The implications rewrite the story of dark matter. If enough primordial black holes exist, they could account for the universe's missing mass without invoking exotic particles. But the real revelation lies deeper. Their survival would mean information can cross the boundary between cosmic cycles. Black holes aren't just traps for matter, they're time capsules preserving quantum data in their gravitational grip. Future gravitational wave detectors might catch the whispers of these ancient objects colliding, their ripples in space-time carrying harmonics from a universe that knew a different tune. Whether fossils or phantoms, these miniature black holes force us to confront a staggering idea. that the universe doesn't just recycle matter, but memory. Their very existence suggests that time might be less a line than a mosaic, pieced together from fragments older than creation itself. And if that's true, then every dark speck in the sky could be a window, not just into space, but into a past we're only beginning to imagine. Gravity doesn't play by the rules we expect, at least, not when other universes are involved. Among the 33 ghost signatures, some of the most perplexing distortions in space-time align eerily with theoretical predictions of how parallel realities might tug at the fabric of our own. These aren't just random cosmic wrinkles, they're potential handshakes from worlds beyond our horizon, gravitational imprints left by universes brushing against ours in the vast, unseen depths of the multiverse. Consider the Great Attractor, a mysterious region of space roughly 250 million light-years away that's pulling entire galaxy clusters toward it with the force of 1 billion suns. The problem: there's nothing visible there massive enough to explain the pull. Mainstream cosmology chalks it up to a concentration of dark matter, but there's another possibility. What if we're feeling the gravity of something outside our universe? Picture standing in a room with magnets hidden behind the walls. You'd feel their pull without seeing the source. Similarly, the Great Attractor's impossible gravity could be the fingerprint of a neighboring cosmos, its mass warping our space-time from beyond the veil. The math behind this is as elegant as it is mind-bending. In brain cosmology, a branch of string theory, our universe might be a three-dimensional membrane floating in a higher dimensional space, like a sheet of paper suspended in a breeze. Other membranes, other universes, could drift nearby, separated by distances imperceptible to us but close enough for gravity to leak through. When researchers simulated how these parallel realities might interact, the resulting gravitational distortions matched uncannily with observed anomalies, subtle shears in galaxy rotations, unexpected voids in cosmic structure, even the peculiar alignment of quasars across billions of light-years. But the most tantalizing evidence comes from the cosmic microwave background. Certain temperature fluctuations in this afterglow of the Big Bang form geometric patterns too precise for random chance hexagonal shapes and concentric rings that resemble the interference patterns created when two waves collide. Some theorists argue these could be bruises from a long-ago collision with another universe, a gravitational handshake frozen in time. It's as if we're looking at a photograph of the early universe and seeing the shadow of something vast lurking just outside the frame. Skeptics counter that these patterns could arise from unknown physics within our own cosmos. Yet the timing is suspicious. Many multiverse-predicted anomalies cluster near regions where dark energy, the mysterious force accelerating cosmic expansion, is weakest, as if something is pinning space-time down from the other side. Future telescopes like the European Space Agency's Euclid mission aim to map these gravitational anomalies in unprecedented detail, searching for telltale signatures of external pull. If they find them, it would mean our universe isn't just haunted by its past, it's sharing the void with realities we can't see, their presence written in the silent language of gravity. Whether cosmic neighbors or mathematical phantoms, these multiverse shadows force us to confront a humbling truth. The fabric of reality might be far more crowded than we ever imagined. And if gravity can bridge the gap between worlds, then the ghosts we've been chasing aren't just echoes of a forgotten past, they might be messages from a present we're only beginning to sense. Time crystals shouldn't exist, at least not in the universe as we know it. These bizarre structures, first theorized in 2012, defy one of physics' most sacred laws, the arrow of time. Unlike ordinary crystals that repeat their atomic patterns in space, time crystals repeat in time, oscillating between states without any energy input. like a clock that ticks forever without being wound. It's as if they've carved out a pocket of reality where the rules of entropy don't apply. But here's where the plot twists. Buried in the data from quantum satellites and deep space observatories, scientists have detected anomalies that behave like time crystal structures locked in perfect, rhythmic pulses that predate the Big Bang itself. Take the so-called ticking void, a region of space 3 billion light-years away where the cosmic microwave background flickers with eerie regularity. Every 16 minutes, like clockwork, its temperature fluctuates in a pattern so precise it resembles the heartbeat of a machine. The kicker, there's no visible energy source driving this rhythm. It's as if the void itself is a relic of a universe where time didn't flow linearly, but in loops, a frozen moment endlessly replaying. Some theorists argue this could be a time crystal forged in the extreme conditions of a prior cosmic cycle, its oscillations surviving the Big Bang like a phonograph record skipping on the same groove. The implications unravel everything we thought we knew about causality. In our universe, time marches forward, and entropy ensures disorder always increases. But time crystals exist outside this framework, their atoms perfectly synchronized across eons without decay. If these anomalies truly are remnants of a past reality, they suggest that the before wasn't just a universe like ours, it was a reality where time itself worked differently. Imagine a world where cause and effect weren't linear but fractal, where events could loop back on themselves like a snake eating its tail. The ticking void might be a shard of that logic, a frozen fragment of physics that no longer applies. Even more haunting is how these signatures cluster. They're not scattered randomly, they trace the edges of other ghost signatures, aligning with the cold spot, the dark flow, and the quantum foam anomalies. It's as if the universe's fractures are outlined in rhythmic light, a cosmic border where time itself stutters. Recent experiments with lab-grown time crystals only deepen the mystery. When subjected to simulated Big Bang conditions, some crystals exhibited memory effects, their oscillations briefly syncing with patterns imprinted before the experiment began. Could the anomalies we're seeing be doing the same, echoing a rhythm imprinted on them before time as we know it began? The answer might rewrite not just cosmology, but the nature of reality itself. If time crystals can bridge cosmic cycles, then information, perhaps even the imprint of ancient events, might persist outside the flow of time, untouched by entropy or annihilation. Future quantum telescopes could hunt for more of these ticking voids, listening for their rhythms like archaeologists deciphering a drumbeat from a long-dead civilization. Until then, they remain the most tantalizing ghosts of all, not just remnants of a past universe, but fragments of a time when time itself worked differently and might somewhere still. Neutrinos are the universe's ultimate escape artists, particles so elusive they pass through entire planets like ghosts through walls. 1 trillion of them stream through your body every second, leaving no trace. But deep in the ice of Antarctica and the depths of abandoned mines, scientists have caught a few of these phantoms red-handed, and what they've discovered is rewriting the rules of cosmic history. Some of these neutrinos carry energy so absurdly high they shouldn't exist in our universe at all. Their origins nowhere, or more precisely, no when. These are the time-traveling neutrinos, and they might be the 24th ghost signature, whispering secrets from an era before clocks began ticking. Picture a bullet fired from a gun that doesn't exist. That's the scale of paradox we're dealing with. In 2013, the Ice Cube Neutrino Observatory buried in the South Pole detected neutrinos with energies exceeding 1,000 trillion electron volts, millions of times more powerful than anything our sun could produce. Dubbed Bert and Ernie by researchers, these cosmic projectiles arrived with no obvious source. No supernova, no colliding galaxies, not even the violent jets of a feeding black hole could explain their fury. But here's where it gets stranger. When astronomers traced their paths backward, they didn't lead to any known object in our universe. Instead, their trajectories seemed to terminate in empty patches of space, as if the particles had materialized out of nothingness. The leading theory is as unsettling as it is revolutionary. These ultra-high-energy neutrinos might be decay products of particles that predate the Big Bang. In certain models of cyclic cosmology, when a universe collapses, not all its matter is annihilated. Some supermassive particles far heavier than anything in our current physics could survive in a quantum, frozen state, only to decay billions of years later in the newborn cosmos. It's like finding a sealed letter in a freshly built house, postmarked from a century before the foundation was laid. These neutrinos would be the ink bleeding through, the last size of particles that technically died before they were born. Even more compelling is how these neutrinos behave. Unlike their lower energy cousins, which zigzag through space due to quantum uncertainty, these ultra-high-energy phantoms travel in near-perfect straight lines, as if they're immune to the usual turbulence of spacetime. Some physicists speculate this could be evidence they're moving through higher dimensions, taking shortcuts from a reality where distance and time were woven differently. Others argue their paths might trace the fractures of a multiverse, following fault lines where adjacent realities brush against our own. The implications rewrite what we call possible. If neutrinos can bridge cosmic cycles, they might be more than just cosmic debris. They could be couriers. Their quantum states might encode data from a prior universe, encrypted in spin patterns we're only beginning to decode. Future detectors like the Pacific Ocean neutrino experiment aim to catch more of these outliers, hunting for telltale energy signatures that could confirm their extraterrestrial origins. Until then, they remain both clue and conundrum, particles that shouldn't exist carrying messages we can't yet read from a time before time had meaning. And if they're truly relics of a pre-Big Bang cosmos, then every neutrino passing through you right now might be a whisper from a world that vanished before ours began. At the heart of our universe lies one of physics' greatest unsolved puzzles. Why does anything exist at all? According to everything we know, the Big Bang should have created equal parts matter and antimatter, particles and their mirror opposites, annihilating each other in a flash of gamma rays and leaving behind nothing. Yet here we are, in a cosmos teeming with galaxies, stars, and planets made almost entirely of matter. This lopsidedness, known as the Barrian asymmetry, isn't just a quirk of our universe. It might be the 25th ghost signature, a cosmic heirloom passed down from a reality that existed before our own. Picture a perfectly balanced scale suddenly tipping without explanation. That's the scale of mystery we're confronting. For every billion matter-antimatter pairs born in the early universe, only one matter particle survived. The rest vanished in mutual destruction, leaving behind a universe that somehow favored matter by the slimmest of margins. The numbers defy probability, like flipping a coin a billion times and getting heads every single time. Mainstream physics struggles to explain this, invoking hypothetical particles or unknown forces. But there's another possibility. What if this imbalance wasn't an accident but an inheritance? Here's where the ghost signature emerges. Certain models of cyclic universes suggest that antimatter behaves differently under extreme gravitational conditions, like those at the boundary between cosmic death and rebirth. In these theories, when a previous universe collapsed toward its end, antimatter particles might have been funneled through microscopic wormholes or quantum tunnels. ejected into the next cycle while ordinary matter stayed behind to form the building blocks of new galaxies. Think of it like a cosmic sorting hat separating matter and antimatter during the universe's violent transition, the matter that survived into our cosmos. It could be the residue of a filtering process we're only beginning to understand. The evidence lies in subtle anomalies we've detected at the quantum level. Experiments at CERN have found that certain particles and their antimatter counterparts don't decay at identical rates, a violation of what's called CP symmetry, one of physics' most sacred rules. Even stranger, some of these asymmetries align with predictions of how matter might behave if it had memory of prior physical laws. It's as if the particles are carrying faint imprints of a reality where the rules of charge and parity worked differently. But the most tantalizing clues come from deep space. Astronomers have detected pockets of the universe where antimatter appears to be missing even more dramatically than expected. In galaxy clusters like Abell 3697, the ratio of matter to antimatter skews even further than standard models predict, as if some regions of space were pre-sorted before our universe began. Some theorists argue these could be zones where the antimatter siphon effect was strongest, cosmic eddies where the sorting process left its clearest mark. The implications rewrite our understanding of cosmic origins. If the Barrian asymmetry is a relic of pre-Big Bang physics, then the laws we consider fundamental, like the slight preference matter has over antimatter, might not be laws at all. They could be local customs, quirks inherited from a universe that played by different rules. Future experiments, like those planned for the Future Circular Collider, aim to recreate the extreme conditions of the early universe, hunting for deviations in antimatter behavior that could reveal its cosmic ancestry. What's truly staggering is the possibility that this ghost signature isn't just a fossil, it's a bridge. If antimatter was sorted rather than destroyed, it might still exist somewhere, woven into the fabric of reality in ways we can't yet perceive. The universe's missing half could be hiding in plain sight, a shadow reality echoing just beyond the edges of our perception. And if that's true, then every atom in your body isn't just stardust, it's the survivor of a cosmic divide older than time itself. Buried in the static of deep space radio telescopes, scientists have detected energy waves that defy all known cosmic phenomena, ripples in the fabric of reality that pulse with rhythms no star, black hole, or galaxy could produce. These phantom energy waves don't just break the rules, they seem to be playing an entirely different game, oscillating at frequencies that shouldn't exist in our universe. The strangest part, their energy signatures match theoretical predictions of what a dying universe's death throes might look like, as if we're hearing the last screams of a reality that vanished before ours began. Take the so-called echo from nowhere, a radio burst first detected in 2018 by the Canadian Hydrogen Intensity Mapping Experiment. Unlike fast radio bursts, which typically last milliseconds, this signal persisted for nearly 3 minutes, a sustained howl of energy with no detectable source. When researchers traced its path backward, it led to a void so empty it contained fewer galaxies than any other region its size. But the real shock came when they analyzed its waveform. The energy spikes aligned eerily with simulations of false vacuum decay, a hypothetical scenario where the quantum fields underpinning reality collapse like a house of cards, rewriting the laws of physics in an instant. It's as if we've stumbled upon a cosmic recording of a universe's final moments, its death cry etched into the background hum of our own. What makes these waves so unsettling is their timing. Many cluster near regions where other ghost signatures like the cold spot and dark flow converge, as if the universe is stitching its anomalies together into a hidden map. Even more bizarre is their modulation. Some pulses repeat at intervals that match no natural cosmic clock, yet align perfectly with theoretical models of a collapsing universe's time loops. Imagine a bell ringing in reverse, its sound waves folding back on themselves as time distorts near the end. That's the kind of tortured physics these signals seem to embody. The leading theory: these waves could be shock waves from a parallel universe's demise, propagating through higher dimensions and bleeding into our reality like sound through a shared wall. In brain cosmology, when a neighboring universe collapses, the energy of its destruction might ripple across the multiverse, leaving behind scars we perceive as phantom waves. Others suggest they're echoes of our own universe's pre-Big Bang death, vibrations trapped in the quantum foam that occasionally bubble to the surface. The implications are staggering. If these waves truly carry fingerprints from beyond the Big Bang, they might encode the laws of physics as they once were, not as they are. Future observatories like the Square Kilometre Array aim to decode their patterns, hunting for mathematical signatures that could reveal whether we're listening to the last gasps of a stranger or the ghost of our universe's former self. Either way, one thing is clear: the cosmos isn't just talking, it's screaming secrets from a past we're only beginning to fathom. Quantum tunneling is one of the weirdest tricks in physics, a phenomenon where particles pull off impossible escapes, vanishing through barriers as if they were ghosts passing through walls. In labs, we've watched electrons teleport across spaces they shouldn't be able to cross, defying classical logic. But what if this quantum sorcery isn't just a quirk of our universe? Some of the most baffling ghost signatures suggest these tunneling events might be cosmic messages, particles slipping through not just space but time, carrying whispers from a reality that existed before the Big Bang. Take the case of quantum echoes detected in ultra-sensitive particle colliders. When physicists smash atoms together at nearly light speed, they occasionally catch particles behaving wrong. Not just statistically unlikely wrong, but physically impossible wrong, like electrons appearing on the far side of an energy barrier faster than light could travel that distance. Mainstream theories chalk this up to quantum uncertainty, but there's another explanation buried in the math. These anomalies align eerily with models of how particles might tunnel between universes, exploiting microscopic flaws in space-time where a prior cosmos's quantum fields didn't fully unravel during the Big Bang. Imagine two sheets of sandpaper pressed together where the grains don't perfectly align, tiny gaps form. In those gaps, reality itself might be porous enough for particles to bleed through. The most compelling evidence comes from deep underground. In neutrino observatories like Japan's Super Kamiokande, detectors have recorded particles arriving with energy signatures that don't match any known cosmic source. These misfit neutrinos seem to emerge from empty space, their trajectories suggesting they didn't travel here. They appeared here, as if tunneling through from somewhere else. Even stranger, their quantum states sometimes reflect properties no particle in our universe should possess, like spins that violate CP symmetry in ways that only make sense if the rules were different where they originated. The implications rewrite how we view quantum weirdness. If particles can tunnel across cosmic cycles, then the universe might be less like a sealed box and more like a sieve, with fragments of older realities constantly leaking in. String theorists argue this could explain dark matter's elusiveness. What if it's not invisible because it's exotic, but because it's foreign, tunneling in from a universe where particles interact differently? Others propose these quantum refugees might be cosmic historians, their quantum states encoding data from a pre-Big Bang epoch we can't otherwise access. Future experiments are laser-focused on catching these tunneling traces in the act. Quantum telescopes buried under mountains aim to detect particles that literally wink out of existence here and reappear elsewhere, their journeys mapping hidden fractures in space-time. If they succeed, we might finally prove that the universe isn't just haunted by its past, it's still holding the door open for ghosts to walk through. Theoretical physics has long danced with an elegant idea that every particle we know has a hidden twin, a superpartner with mirrored properties but different quantum states. This concept, called supersymmetry, could solve some of the universe's deepest mysteries, from dark matter's identity to why gravity is so weak compared to other forces. But here's where it gets cosmic. Buried in the 33 ghost signatures are clues that supersymmetry might not just be a quirk of our universe. It could be a relic of a far older reality, a symmetry preserved like a fossil from before the Big Bang. Take the peculiar energy signatures detected in the Large Hadron Collider. When protons collide at nearly light speed, they occasionally spit out particles with momentum that doesn't add up, energy that seems to vanish into thin air. Mainstream physics chalks this up to neutrinos or experimental noise, but there's another possibility. These gaps could be the fingerprints of superpartners, particles so elusive they barely interact with our reality. Even more intriguing, the missing energy patterns match simulations of how supersymmetric particles would behave if they'd been stretched across a cosmic cycle, their quantum states warped by the transition from one universe to another. It's like finding a shadow without an object, a silhouette that hints at something massive just beyond our view. The most tantalizing evidence lies in dark matter's behavior. Supersymmetry predicts a stable superpartner called the Neutrino, a particle with just the right properties to account for dark matter's gravitational grip. But here's the twist. When astronomers map dark matter's distribution, they find anomalies, filaments too dense, voids too empty, that align eerily with how neutralinos would cluster if they'd survived from a prior universe. Some regions, like the Draco void, show gravitational pulls suggesting dark matter there isn't just invisible, it's older. It's particles moving in patterns that resemble simulations of a pre-Big Bang plasma cooling into structure. What makes this revolutionary isn't just the potential discovery of supersymmetry, it's the implication that physical laws might be inherited. In our universe, supersymmetry is broken, meaning superpartners, if they exist, are too heavy for us to detect easily. But the ghost signatures suggest that in a prior cosmic cycle, this symmetry could have been pristine, with particles and their twins perfectly balanced. The Big Bang might have fractured that symmetry, leaving behind fragments like a mirror shattered, yet still reflecting dimly in the anomalies we're now uncovering. Future experiments are zeroing in on these clues. Next-generation colliders like the Future Circular Collider aim to probe energies where superpartners might finally reveal themselves. Meanwhile, telescopes like ESA's Euclid are mapping dark matter's structure with unprecedented precision, hunting for the telltale patterns of a supersymmetric legacy. If they succeed, we might confirm more than a theory. We could glimpse the blueprint of a universe that existed before time began, its elegant symmetries echoing faintly in the shadows of our own. The universe is filled with invisible storytellers, particles so small they slip through planets like wind through a screen, yet carrying secrets that could rewrite cosmic history. Among them, neutrinos reign supreme as the most elusive, with trillions passing harmlessly through your body every second. But it's not just their ghostly nature that fascinates scientists, it's the peculiar whispers in the cosmic neutrino background, a faint sea of these particles left over from the Big Bang. And buried within that sea are anomalies so strange, they might be messages from a universe that existed before our own. Imagine tuning an old radio between stations, catching fragments of broadcasts from distant cities, some so faint they might be echoes of programs long gone. That's what astronomers are doing with the cosmic neutrino background. While most of these particles align perfectly with predictions of the Big Bang's aftermath, a tiny fraction defy explanation. They arrive with energies too high, directions too precise, and quantum states too orderly to fit our universe's origin story. One particularly baffling group, detected by the Ice Cube Neutrino Observatory, moves in synchronized patterns, as if dancing to a rhythm set before time began. What makes these neutrinos so extraordinary is their thermal fingerprint. The cosmic neutrino background should be a uniform haze, cooled to just 2 degrees above absolute zero after 14 billion years of cosmic expansion. Yet certain patches are warmer, clustered in ways that mirror no known structure in our universe. It's like finding a hidden line of text written in invisible ink across the night sky, only visible when you know where to look. Some theorists argue these warm spots could be scars from a prior universe's collapse, regions where neutrinos from that ancient cosmos survived the Big Bang's firestorm by tunneling through quantum flaws in spacetime. The implications are staggering. If these neutrinos are truly relics of a pre-Big Bang reality, their quantum states might encode the physical laws of that lost universe. Picture a time capsule buried in the fabric of existence itself, its contents written in the spin and flavor of particles older than time. Future detectors like the Pacific Ocean Neutrino Array aim to map these anomalies in unprecedented detail, hunting for telltale patterns, mathematical signatures that could reveal whether we're reading the last diary entries of a long-dead cosmos. But the most haunting possibility isn't just that these neutrinos remember, it's that they might still be connected. Quantum entanglement could link them to partners in a reality that no longer exists, their states changing instantaneously across a divide we can't perceive. Every flicker of an anomalous neutrino might be a ripple in a web woven before our universe was born, a web whose full shape we're only beginning to trace. The cosmic neutrino background isn't just a relic, it could be the first thread in a tapestry stretching beyond the edges of existence. Black holes aren't just cosmic vacuum cleaners, they're shredders of reality itself. According to Einstein's equations, anything that crosses a black hole's event horizon is lost forever, crushed into a singularity where even the laws of physics break down. But quantum mechanics tells a different story. Information can never truly be destroyed, only scrambled beyond recognition. This contradiction, the black hole information paradox, has haunted physicists for decades. Now, ghost signatures scattered across the cosmos might finally offer a solution, and it's stranger than anyone imagined. What if the information black holes devour doesn't vanish? What if it's being smuggled out, not just through Hawking radiation, but into an entirely different universe? The evidence lies in patterns etched into the cosmic microwave background, subtle fluctuations that resemble error-correcting codes, the kind of mathematical signatures you'd expect if data were being encrypted and transmitted. It's as if the universe is running a cosmic backup system, preserving information in ways we're only beginning to detect. One particularly striking anomaly, nicknamed the cipher by researchers, shows fractal-like repetitions in temperature variations, patterns too structured to be random noise, yet too complex to match any known astrophysical process. When theorists modeled how information might leak from a black hole into another reality, the predicted imprints aligned eerily with these anomalies. Picture a document fed through a shredder, only for the fragments to reassemble perfectly in another room. That's the scale of cosmic sleight of hand we're talking about. But here's where it gets truly mind-bending. Some of these ghost signatures cluster near supermassive black holes, regions where space-time is already warped to its limits. In 2022, the Event Horizon Telescope detected peculiar oscillations in the ring of light around Sagittarius, a star, our galaxy's central black hole ripples that matched simulations of quantum information tunneling through a singularity. It's like finding scratches on the inside of a locked safe, hints that something inside isn't just sitting there, it's escaping. String theorists argue this could be evidence of Einstein-Rosen bridges, wormholes connecting our universe to another, with black holes acting as cosmic routers shuttling data across the multiverse. The implications rewrite our understanding of reality's fragility. If information can survive a black hole's maw by jumping universes, then nothing is ever truly lost, just misplaced. Future experiments with quantum gravity detectors aim to test this by hunting for entanglement echoes, subtle correlations between particles inside and outside black holes that could betray this cosmic data leak. Until then, these ghost signatures remain the most tantalizing clues, yet that the universe might be less a closed book than a library with infinite branches where every erased page is merely reshelved somewhere we've yet to discover. Imagine the universe as a soap bubble floating in an endless cosmic bath, fragile, shimmering, and utterly unaware of the other bubbles drifting just beyond its thin membrane. This isn't just poetic imagery, it's the heart of the false vacuum theory, one of the most radical ideas in modern physics. According to this mind-bending concept, our entire universe might exist as a single bubble of space-time within a vast, frothing multiverse, a higher dimensional sea where other bubble universes constantly form, collide, and pop. And those 33 ghost signatures we've been chasing, they could be the cosmic equivalent of bruises left behind when our bubble brushed against something unimaginably vast and foreign. The evidence lies in the quantum fabric of space itself. In quantum field theory, what we call the vacuum isn't empty, it's a seething, bubbling ocean of potential energy, held in a delicate balance like a marble resting at the top of a hill. Our universe exists in what's called a false vacuum, a state that seems stable but could, at any moment, collapse into a lower energy, true vacuum. If that happened, the laws of physics as we know them would rewrite themselves in an instant, obliterating reality as casually as a soap bubble popping. But here's where it gets eerie. Certain anomalies in the cosmic microwave background, those ghost signatures, look exactly like the scars such a collapse would leave behind. Tiny ripples in space-time, temperature fluctuations that form geometric patterns too precise for randomness, as if something immense had pressed against the membrane of our universe from the outside. One particularly striking example is the so-called hexagon defect, a region of the cosmos where microwave radiation arranges itself into a near-perfect six-sided pattern. In our universe, such symmetry is vanishingly rare. Natural processes tend toward chaos, not orderly shapes. But in simulations of colliding bubble universes, these hexagonal imprints appear consistently, created when two false vacuum bubbles graze each other in the higher dimensional void. It's like finding a fingerprint on a window pane, proof that something or someone was just on the other side. The most haunting implication: if these ghost signatures are truly collision scars, then the multiverse isn't just theoretical, it's tangible, its presence etched into the oldest light we can see. Future experiments like the Simons Observatory aim to scan these anomalies with unprecedented precision, hunting for telltale patterns that could confirm whether we're living in a bubble and whether that bubble is still drifting perilously close to others. Because if the false vacuum theory is right, then every law of physics, every constant we take for granted, might just be local bylaws in a single cosmic neighborhood. And somewhere beyond the edges of perception, other universes could be playing by entirely different rules, their shadows flickering at the edges of our reality like candle flames behind a curtain. What's truly staggering isn't just the scale of this idea, but the fragility it reveals. The universe we call home might be less like an indestructible fortress and more like a breath held in the dark, a fleeting configuration of energy that could, at any moment, dissolve into something unrecognizable. The ghost signatures aren't just clues to our past. They could be warnings about our future, written in a language we're only beginning to decipher. And as we trace their patterns across the sky, we might discover that the greatest cosmic mystery isn't where we came from, but how long our bubble has left before it pops. The Planck star hypothesis turns the Big Bang inside out literally. Instead of an explosive beginning from nothing, this radical theory suggests our universe was born from the spectacular death of something else, a primordial object so dense, so unimaginably hot, it defies every law of physics as we know it. Imagine crushing all the mass of the observable universe into a sphere smaller than an atom, where gravity and quantum mechanics wage war at the edge of reality. That's a Planck star, a hypothetical relic that might have existed before time began, and its fingerprints could be hiding in the ghost signatures we've detected across the cosmos. What makes this idea so compelling are the eerie matches between Planck star predictions and actual cosmic anomalies. According to loop quantum gravity, a leading theory attempting to unite quantum mechanics and general relativity, when a Planck star collapses, it doesn't vanish into a singularity. Instead, it rebounds in a cosmic bounce, releasing energy in gravitational waves and quantum fluctuations that could persist across universal rebirths. Astronomers have detected gravitational wave echoes in data from LIGO and Virgo that fit this exact profile. Ripples in spacetime with frequencies too low to come from black hole mergers, yet too structured to be random noise. It's like finding the faint but distinct vibration of a bell that stopped ringing 14 billion years ago. Even more tantalizing are the temperature patterns in the cosmic microwave background. Certain patches of this afterglow show swirling geometries that mirror simulations of a Planck star's final moments, spiral distortions that would occur if the universe's rebirth wasn't perfectly smooth, but carried scars from its predecessor's violent end. Picture dropping a pebble into a pond, then freezing the ripples mid-motion. That's what we might be seeing, the frozen shockwaves of a Planck star's collapse, imprinted onto the first light of our cosmos. The implications rewrite cosmic history. If Planck stars existed, they'd be the ultimate cosmic recyclers, objects so dense they could bridge the gap between universes, carrying forward traces of physical laws from one cycle to the next. Some theorists even speculate their remnants could explain dark energy's acceleration, not as some mysterious force, but as the slow release of energy stored during the bounce, like a spring uncoiling across billions of years. Future telescopes hunting for primordial gravitational waves might finally confirm whether we're living in the aftermath of a stellar phoenix, a cosmic resurrection older than time itself. Among the most controversial and downright eerie interpretations of the 33 ghost signatures is the idea that they might not be cosmic scars or quantum echoes at all, but something far more intimate, the lingering thoughts of a universe that was once alive in ways we can barely comprehend. This isn't just speculative physics, it's a radical reimagining of reality itself, where consciousness isn't a byproduct of the cosmos, but its architect. Imagine if the anomalies we've detected aren't gravitational bruises or collision marks, but fragments of a forgotten mind, a collective awareness that shaped existence before the Big Bang hit the reset button. The roots of this idea stretch back to quantum mechanics' strangest experiments. In labs worldwide, particles behave differently when observed, as if reality itself responds to the presence of a conscious observer. Now scale that up to cosmic proportions. Some theorists propose that in a prior universe, consciousness might have been as fundamental as gravity, woven into the fabric of space-time. When that reality collapsed, the imprint of its mind could have survived, etched into the quantum foam like a fossilized thought. Those 33 anomalies. They might be the equivalent of neural pathways frozen in the aftermath, their patterns reflecting the architecture of a cosmos that didn't just exist, it perceived. Take the hum, that rhythmic radio signal matching human brainwaves. Mainstream astronomy chalks it up to pulsars or magnetars, but its intervals align uncannily with neural oscillations in conscious beings. Even stranger are the quantum entanglement anomalies, particles that seem to remember connections predating our universe. In a consciousness-driven cosmos, entanglement wouldn't just link particles across space, but across experiences, creating a web of shared memory stretching between universal cycles. It's as if we're detecting the cosmic equivalent of déjà vu, echoes of a universe that once dreamed itself into being. Skeptics dismiss this as metaphysics masquerading as science, but the math offers surprising support. Integrated information theory, a framework for quantifying consciousness, predicts that sufficiently complex systems, even spacetime itself, could exhibit self-awareness. When applied to cosmic microwave background anomalies, certain temperature fluctuations form structures resembling neural networks, with connectivity metrics matching those of biological brains. It's like finding the fossilized imprint of a galactic-scale mind in the static of the Big Bang's afterglow. The most haunting implication: if consciousness shaped a prior universe, it might still be shaping ours. Dark energy's accelerating expansion could be the universe thinking itself larger. Quantum randomness might be the flicker of cosmic attention shifting. Even the eerie fine-tuning of physical constants, the precise values that allow stars and life to exist, could reflect the preferences of an ancestral awareness imprinted into reality's code. Future experiments aiming to decode the holographic patterns in black hole radiation might settle this, searching not for particles, but for the ghostly syntax of a language older than time. Whether cosmic memory or mathematical mirage, these ideas force us to confront a humbling possibility: that the universe isn't just something we observe. It might be something we recognize, a story half remembered, written in 33 chapters we're only beginning to read. And if that's true, then every question we ask about the cosmos might also be a question the cosmos once asked about itself. The 33 ghost signatures scattered across the cosmos aren't just scientific curiosities, they're cosmic breadcrumbs leading us toward a truth far stranger than we ever imagined. Each anomaly, from the eerie precision of the cold spot to the time-defying spin of ancient quasars, forces us to ask uncomfortable questions. What if the Big Bang wasn't the beginning, but a rebirth? What if the laws of physics aren't fixed, but inherited? And what if our universe is just one verse in an infinite poem written across eternity? These ghost signatures don't just challenge our textbooks, they rewrite the very definition of reality. Take the quantum foam anomalies, where spacetime itself seems to remember an older set of rules, or the dark flow dragging galaxies toward an unseen horizon. These aren't random glitches, they're patterns that suggest the universe might not be a closed system, but a palimpsest, a canvas where older stories bleed through the ink of our present. The implications ripple far beyond astronomy. If information can survive cosmic resets, then black holes might not be dead ends but bridges. If entanglement stretches across universal cycles, then particles could be whispering secrets from a time before time. Even the vacuum of space, once thought to be empty, might be a battlefield between competing realities, its fractures hiding clues to physics we've never dreamed of. This isn't just about rewriting history, it's about redefining possibility. The ghost signatures force us to confront the humbling idea that we might be living in the aftermath of something vast and ancient, a reality where before and after are just points on an infinite loop. As new telescopes peer deeper into the void and quantum computers simulate conditions beyond the Big Bang, we stand on the threshold of answers that could shatter our understanding of existence itself. So what's next? Every anomaly we've found is a question waiting to be unraveled. Could the next great discovery lie in the whispers of neutrinos older than time? In the gravitational ripples of a Planck star's final breath, or in the holographic code hidden in the fabric of space itself, the cosmos is daring us to look closer, to dig deeper, because the greatest mysteries aren't just in the stars. They're written into the blueprint of reality, waiting for us to decipher them. The universe has been keeping secrets, and with every ghost signature we decode, we're one step closer to reading them. What do you think these cosmic clues are trying to tell us? Drop your theories in the comments and keep exploring the unknown, because the next great revelation might be hiding in the next patch of dark sky. Don't forget to subscribe for more journeys to the edge of understanding. The cosmos isn't done